So, as I said in my brief intro, I'm Craig Russell. I'm here to speak to you about writing good unit tests. I'm going to start with a disclaimer as well, because as soon as someone gets up and says I'm going to talk about good blah blah blah, if I was in the audience, I'd immediately be like, here comes opinions dressed up as facts. So there is going to be some opinions in here, but I make the full disclaimer that it's all subjective. If I say anything that you disagree with, it doesn't mean I'm saying that you're wrong and I'm right. It's just this kind of approach works for me. So I think there's some good value in kind of passing that on for other people. So I am an Android developer. One of my big passions is sharing knowledge. It doesn't matter kind of what team I work in, I like to try and share knowledge. I pair with people, I make sure we do code reviews and all that kind of stuff. Some of the other ways that I try and share my knowledge, I am an instructor on caster.io, which is a service where we develop kind of bite-sized Android educational lessons. I have a whole course on there on kind of good unit testing with Mockito, kind of mirroring this one, but I go into more depth in that course because I've got more time to do it. So if you haven't checked it out before, I'd recommend it. I do things like I blog and I tweet. I spend way too long on Twitter. Handles down the bottom right there. I just, pro tip for you, make sure you don't put anything right to the margin because it might get cut off when you go into that. So to fix it, just last minute there. I'm really active on Twitter, way too active, but I'd love it if you all said hi if you use Twitter. As you can see from my avatar here, I am obviously a nerdy Android developer, but it doesn't quite capture how professional and serious I am. So, hey, you might be thinking, Craig, is this your first time using Keynote to make a presentation? Yes, yes it is. So this is the, oops, jump back, as you can see, it's the first time. So this is the running order. I was originally going to talk about Mockito exclusively. However, I kind of figure that there's some context that you need to understand before I just jump in. And if I just start talking about Mockito, I'd probably bore like 80% of you who didn't use it already. So I'm going to try and talk a little bit first about what problems we face in unit testing, how the likes of a test double can help you solve some of those problems, and then ultimately how Mockito can help you provide those test doubles. So that's the kind of narrative that I'm looking to spin here. So that's the running order. I'm going to talk about what is a good unit test, and again this is a highly opinionated part where this is my characteristics of a good unit test. I'm going to talk about test doubles, how I use them in my day-to-day development, and what kind of problems they can help you solve. And then we're going to talk about Mockito and give you some examples of using those test doubles with Mockito, all demonstrated in that lovely pyramid there. So why do we need to talk first about unit testing and test doubles if we're going to talk about Mockito? So as a wise man once said, it's okay to tell someone how great a screwdriver is, but only if they first know that screws are a thing. Not actually a wise man, I just made that up the other day as I was writing this talk. But kind of extolling the virtues of a tool is kind of useless if your audience doesn't know what problems it solves. So you kind of need to fill that context first, is my thinking. I get criticised for quoting myself in presentations. I disagree fully that it's a bad thing. And yes, you can quote me on that. Pausing whilst Jean takes a photo. Okay, so let's get down to business. So this is kind of the things I'm going to cover as to what makes a good unit test. I'm going to run through each of these in sequence. So how can you keep your unit test fast? So you should avoid making network calls in a unit test, and you should avoid doing things like accessing the database or reading from file storage. And some of the reasons for that is in a typical project, you can easily accrue thousands of unit tests. That's kind of a reasonable sized project, and sort of smaller or less well tested project, there could be hundreds of unit tests, hopefully some unit tests. And you kind of want your whole test suite to run in a matter of seconds if you can, if not a small number of minutes. And the reason why you want that to happen is there's this interesting thing where the longer that your tests take to run, the fewer times that people will run them. So if you're coming from this premise that unit tests are valuable and you should run them often, that's great, but if they take 10 minutes to run, developers are just going to skip it. They're not going to bother with it. So then what happens is they'll just check it in without running their tests, the build will break 20 minutes later, and they've moved on to another task and they'll have to kind of backtrack and just cost a whole load more. If you keep your test suite running fast, you kind of avoid that whole problem. So that's characteristic one. So we can check that off. So the next one is deterministic. What that means to me is that if you run a particular test, it should always pass or it should always fail. Any test which sometimes passes, sometimes fails, you get the false negatives and so on. So I call them flaky tests. And for me, they can kind of undermine the whole confidence in your entire build system. And there's an interesting kind of slightly tangential thing here, but this is why you need to have build confidence. The broken windows theory was kind of introduced in the 80s and has absolutely nothing to do with software. It's all about society and the kind of disorder and crime relationship. So they've done this study and basically they concluded that with a little bit of disorder, that actually encourages crime, which encourages more disorder, and it's this kind of vicious cycle. So disorder and crime just kind of make each other worse. And this is kind of how it relates to software. So if you imagine that your building is your build system, that's what I did there, and you have all these windows which might represent your unit tests. When all the windows are well kept, well maintained, they're all not broken, they're all in nice working order, everyone's happy. But what happens is as soon as you get one broken window in an otherwise perfect building, that's a big deal. You break one window and everyone's compelled to fix it because, my God, there's one single broken window, that's terrible. But if you don't fix it, then you get into the broken window. If you imagine that the build failing, that's a type of disorder, and your broken unit test, that's the crime that you've committed as a developer. And that broken, that disorder will encourage more crime because it's like, well, if one test is allowed to fail every now and again, then I can write a test that fails every now and again. What's the big deal? And if you get the whole sort of mentality of it's all right, they don't have to pass all the time, as long as they pass a reasonable amount of time, then it just kind of goes into a downward spiral, and you'll end up with tests which you can't trust. Really, you can't trust if it's a real failure or not, and you end up in a place that's bad to call home. So you really need to have confidence in your build system. You should never have the scenario whereby a test fails and your team just kind of go, run it again. It might pass the next time. Like that's a known thing with that test. I've been there, it's not pleasant. So that's why kind of deterministic unit tests are a necessity. So let's talk about self-contained. Your unit test suite, you should be able to run tests in any order. What that means is you should be able to pick a single unit test and run that, or a small subset, or the full test suite. And they shouldn't depend on one test having run before another. And what you don't want to do is have your unit test rely on external state being set up. So examples of that would be like a database, or in the worst case scenario, like a network. So I've seen unit tests that will make a call to a network to create a user, and you have to run that test before you go query for the user's existence, or else the whole test suite will fail. Again, that can get into a sort of horrible mess. So you want to try and keep it so that you don't have shared state amongst your tests, and you don't get into the situation where one test can corrupt that shared state for another test and cause that to fail. So just set up each test so that it's self-contained, it has everything it needs to set itself up, execute, and go away without interfering with any other test. And the last characteristic is focused. Ideally, your unit test should interact with a small number of classes, and there's no kind of universal number on what that should be. I try and make it one, so if I write a unit test, I'm hopefully just going to work with one class, but sometimes that class has collaborators that it needs to work with, and sometimes it's acceptable to bring them into your unit test, and sometimes you need to be quite clean about isolating the dependency from it. So I think when it comes to isolating dependencies, that's probably my biggest kind of eureka moment in my testing journey. It was kind of like, okay, I have a class that I want to test, but when I go to instantiate it, I realize that it has dependencies, so it might need this other box. And I go, okay, well, I just need to create one of those as well and feed it to it during testing. But then if that other box also has dependencies, each of which might also have dependencies, suddenly I'm testing a whole subsection of my system. Whereas really right now, I just want to be concentrating on that one yellow box. So for me, it's crucial that you find a way to control and isolate your dependencies so that what you think you're currently unit testing is all that you're currently unit testing. It's fine to test parts of your system, but that's an integration test, that's a system test, it's something else. Talking about unit tests, you've got to have that focus, for me at least. So what you want is a way to get rid of all that and basically have something that you will slot into place. So if you're testing a class and it has an external dependency, you can substitute all the production code out with all of its tangled web of other dependencies and give it something that's easy to control. So, that's my kind of checklist. Again, if you write tests which violate these characteristics and you find that you're getting more value than pain, that's awesome, keep with it. I'm not suggesting you go rewrite anything, but what works for me is bearing this in mind when I'm writing my code. So test double. So moving on to test double. So speaking about the substitute that you slot into place, that blue box that I had on the last slide, they can help keep your unit test sticking to these characteristics. So generally, it's kind of this umbrella term that people will talk about in testing. A test double is just anything that you substitute in place of a real dependency during unit testing. And for me, one of the analogies that I've seen is like test double is like a stunt double. So if you think of sort of Hollywood blockbuster, you've got a big action scene to film, you don't really want to have to get your leading man or leading lady in place to do the scene. They might be sleeping, they might demand breakfast and demand that you talk to their agent and get safety gear and all the rest of it on, whereas that's what stunt doubles are for. So if it's really unnecessary for the scene that you're filming, you can just throw a stunt double in place and you can get the camera rolling a lot quicker, which is kind of what the idea of the test double is. So it's often a lot quicker to set up a test double than it is to set up the real dependencies. And it's also a lot safer to kind of rely on these rather than relying on production code. And I'll go into an example of why it can be safer. So some of the test doubles that you've probably heard of already, things like mocks and stubs, and there's a whole bunch of other ones. I'm only going to talk about mocks and stubs in this talk, and if you're looking for more information, there's a great Martin Fowler blog called Mocks Aren't Stubs. I recommend go read that. He describes all the other ones and talks about different mocking strategies and all the rest of it. It's a really good blog. So this is the example I'm going to take you through. Imagine we are creating a user registration feature, and the idea here is that a user comes along, gives you your email address, and you want to verify if that email address is already in the system. And if it is already in the system, if it's a duplicate, we're going to throw an exception to say, well, you can't register again. And if the email address is not in the system, then you can go ahead and maybe send a verification email. So that's the one, you click the link to verify that you own that email address. And again, if there's any problems that happen during that, you can throw an exception. And then finally, if all goes well, you can go ahead and add that user to your database. So that's the kind of class that we're looking to test in this example. So we need a way of setting the database and email sender objects. So we'll go ahead and add a constructor that lets you stick them in place. I can go into a whole separate talk on why constructor-based parameter injection is a great thing, but I don't have time for that, so I'll just say you need a way to basically set these, that you could set it differently during unit testing than how you do in production code. And basically, constructor-based injection is a great way to do that. So what would happen if you tried to use real dependencies? So basically, if you tried to use a real dependency, you could end up writing slow, non-deterministic, non-self-contained, not focused tests, which conveniently violates all the characteristics that I just laid out. So it could be slow because if you're hitting the database, it could be doing real file I/O operations. It could be non-deterministic because if you're hitting that, that's basically a shared state. Other tests might be modifying it in the same way at the same time. Again, not self-contained, so you've got that external state, and certainly not focused. It might seem like you're just testing the logic of your user registration class, but actually, if you're hitting the database, you're bringing in a whole host of code as well. So that could be like a full database stack. You could be executing SQL, JDBC drivers, like all sorts of stuff is going on. Whilst really all you care about is this one small bit of code, and that's just the database. If you don't want to be sending out real emails, when you're doing your unit testing either. So if you use the real production versions of these things, you're kind of breaking the characteristics of a good unit test and kind of asking for pain. So hopefully you get the idea why sometimes you just need a substitute. The real thing is just not going to do. So in our case, our substitutes are stubs and mocks. So what a stub is a substitute. You can pass it in, and what you can do is you could configure responses that it will respond to you. So you ask it a question, and it will give you this hard-coded response back. Simple example is like I could say to someone, I'm going to ask you what colour the t-shirt I'm wearing, and I want you to tell me it's red. Like, I don't care. I don't need you to use your eyes or observe the way the light's bouncing off my t-shirt and into your system and your brain's processing it. Just tell me it's red. Like, that's all I need to know right now. That could be really useful in a lot of scenarios, so we'll demonstrate that. And the other part of the stub is that you can configure when these hard-coded responses are relayed back to you. So I could say, not only do I want you to say my t-shirt is red, but I only want you to say it's red when I'm standing on one foot. I can make it conditional as well, which is also really useful. So we can do things like for our database, we can say, well, hey, when the hasUser method is called, return false. And for one test, that will let me test that one flow. Or you could do something else. You can say, well, when the hasUser method is true, is called, return true. Or you can make it throw an exception or do nothing or whatever. So these are the kind of the ways in which you can get the stub to work for you, letting you test all branches of your code. So if we revisit our example, if we want to write a test to basically test that when the user already exists, we throw that exception, we can configure the stub to say hasUser is true. Whenever you ask me if I've seen this email address before, I'll just say yes. And then we can verify that that exception is thrown. So if we go ahead and define that unit test, it might look something like this. Should throw exception, add in duplicate email, and you can see at the top we are expecting that registration, user already registered exception to be thrown. So to use Mockito, you would use this kind of syntax. You do mockito.mock. Even though we're creating a stub, you still use mockito.mock. It's kind of a confusing part of the framework, but I'll come back to that. So you call mockito.mock and you give it the class for what you want to create. And the cool thing here is it doesn't matter whether that database.class, whether that's an interface or an actual concrete implementation. Mockito doesn't care. It will give you a stub back to work with. So we can do that for our mock database and our email sender. And we're going to create an instance of user registration because that's the class that we're looking to test right now. So we'll pass them in the constructor. And then this is an example of how you would configure that stub. You say when the hasUser method is called on our database and it's passed this string, I want you to return true. And that string is the conditional part. If you passed a different string, it wouldn't return true. So when I go ahead and call my method and say I want to register a new user and see what happens, that hasUser method will return true. So that exception will be thrown, which means our test will pass. And the cool thing about this is it's really fast. Like I haven't touched a real database, I haven't executed any real queries. So I ran it on my machine just before I came out, if you're wondering how fast. Like 0 milliseconds. Don't get much faster than that. So it takes somewhere between 0 and 1 millisecond to run that test, which is kind of awesome if you go back to the earlier point of having thousands or even hundreds of unit tests in there. So that's nice. So that's a stub. Let's talk about mocks. Mock can be used to verify the interaction with a dependency. So the idea here is that you can execute your test and then come along and verify that things happened to your dependency that you thought were going to happen. So kind of examples in the context of the problem, you can come along and say, I want to make sure that my addUser method was called. And I want to make sure it was called exactly once, because I know if it's called multiple times, that's confusing. Or for a different test, you can come along and say, I want to make sure that that's never called. Or you can even go further and you can say, well, I want to make sure it's called and I want to make sure it has this exact string passed to it, which was the string that I passed into the register method in the first place. So mocks are pretty powerful in that sense. And if we jump back to our example, so if the database does not have the user already and the email send worked successfully, I'm now at this part, I want to add the user to my database. And to write a test for this, I need some way of knowing that that call happened. It doesn't return a boolean or anything to indicate a success. It's really difficult to know whether that happened unless you're using a mock. So that mock gives us the ability to jump in and verify that that interaction did take place. So if we were to write that as a unit test, should add new user to the database, we can come along and we've got the exact same setup method as before. So again, even though I'm now using it as a mock rather than a stub, I still call mockito.mock to create an instance on my database and email sender, and then I pass that into my user registration class. So that's the exact same setup as before. This time, define my email address as before, and I configure the stub to say, hey, when I call hasUser, return false, because I want to get past that check and move on to the next thing. And I also have to do the, when you try and send an email, tell me that was successful, because I want to pass on to that. And you can come back and write other tests to test when that was unsuccessful and so on as well. And then finally, I execute my code. And then unlike, well, the thing you want to do now, you've executed the code and you want to go back and you want to verify that things happened as you expected. So mockito.verify lets you do that. So you can do, I want to verify that that addUser method was called on my database. And you're saying, I want to make sure it's pass this exact parameter. And that verify will throw an assertion error if that fails. So your test will fail if it didn't happen. And implicitly, it's saying that will happen once. You can go in and say, I want it to be at least 5 times, or you can want it to say, I want it to happen exactly 4 times. It's got all this kind of built into it, but implicitly that's just saying I want to make sure that happened once. So that makes what would otherwise be quite a tricky thing to test pretty trivial to test, I would say. And at this point you might be thinking, well, these mocks and stubs things, they sound pretty easy. I could go write my own, and you possibly even are for some of your unit tests, and you've probably sort of made an object that you interact with and you set a flag to say, did this method get called, or you incremented a counter that every time you called it and so on. Again, it's fine if that's working for you, but I am only really scratching the surface of what Mockito can do. So it's got a huge number of things it can do for you. So I would strongly recommend that you consider an existing solution. And it just so happens I would recommend one. I'd recommend Mockito, as it turns out. It is a library for creating test doubles. It's really confusing the names. If you talk about Mockito, people will think, well, you must be dealing with mocks, but it deals with all of them. So even though all of the kind of annotations are like Mockito.mock or mock this and so on, you can get that same object back, but use it as a mock or use it as a stub. It kind of depends what you do with it. It's available for Android as well as plain old Java testing. And yeah, it covers all of the test doubles, makes that available for all of them. As I mentioned previously, it works on classes and interfaces, which is quite powerful as well. So quite often when you've got a method, you might be inclined to pass in an interface so that during testing, you can provide a different implementation of that interface than you do for production. That can get a little bit cumbersome if you're doing sort of internal stuff, if it's not like a public API. If you have to make an interface for basically every class, that gets quite clunky in my opinion. So the fact that you can come along and mock a class just as easily as you can mock an interface is pretty useful. And a very recent addition is that you can use it on final classes. So previously, any classes marked as final were just unmockable using Mockito. You had to kind of use a whole bunch of other tools. But just as of their latest version, they've made it so that you can mock final classes. So, kind of wrapping up, I spoke about unit testing. I gave you my opinion on kind of some of the things that a unit test is and some of the things that you should try and avoid doing during a unit test. I spoke about test doubles, these umbrella terms that is just basically a substitute for any real dependency. And I spoke about stubs, which is a type of test double, and how it allows you to get something to parrot responses back to you. And I spoke about mocks, which lets you verify the interactions with a particular dependency. So as well as saying, I want to make sure this interaction happened, you could say, I want to make sure this interaction didn't happen. And that could be useful in other scenarios as well. And that's a kind of summary of the kind of syntax you would use to do this in Mockito. So there's our stub for configuring, tell me has user is false when I ask you, and make sure that the add user method was called when I come to check it. So to finally wrap up, that is my opinion on some of the stuff that I do when I'm doing coding. If you find that you do things differently, I'm not suggesting you go away and rewrite it. It's all about basically getting the value from your tests. If you think your tests are giving you a lot of value and they're not hard to maintain and they don't fail often, then you're doing something right, that's great. But if you do recognize any of these problems that I'm talking about, then maybe you can have a look at test doubles and see if they could possibly help make your tests a bit more stable or a bit quicker or whatever. And if you are going to look at a test double framework, then I would recommend Mockito. It's my favorite by far. I'll slip this in. I am finishing up my current role and I'll be looking for my next adventure. So if you're looking for someone who is passionate and very, very opinionated and really enjoys unit testing, come have a chat to me. I'm not going to be able to stay right to the end tonight, but if you grab me on Twitter, I'm more than happy to have a chat there. Time for questions, or have I overran too much?
Any questions in there? Any questions for me?
Hello.
Have you used Mockito with Kotlin?
I have not. I've only dabbled with Kotlin. And by dabbled, I have one side project which I started for a few hours just to play around with it.
That's about my experience as well. I was just wondering because you mentioned you defining mock final passes and obviously Kotlin is final by default.
Yes, I've seen people chat about the fact that everything's kind of final by default. I don't know if the recent addition, Mockito used to use, I think, like cglib under the hood to do its it's mocking, and one of the limitations was it couldn't do final classes. So it recently, as of the 2.0, moved to ByteBuddy to do it. I don't know if that enables Kotlin or not, or if it's still an additional problem.
I was just wondering if
Yeah, but no, very little Kotlin experience.
Have you found any? Sorry.
Yep.
Have you found any downsides with using Mockito 2.x on Android?
No, I've used Mockito 2.x for so long, and as beta, I've been using it for a couple of years. Because I think the last stable version of 1 was like 2014.
Yeah.
So I've always been like, what? That's old. There's this 2 branch. I'm just going to use that. So I couldn't even tell you the differences because I've always used 2 essentially.
Yeah.
So if there are downsides, then I haven't experienced them because that's all I've experienced.
We tried changing it an hour from 1.10 to 2, and a lot of tests broke. I don't know why.
That'd be a nice exercise because it was only released recently, so I don't know if you tried the beta version or if it was the 2.0 stable.
I don't remember.
2.0 stable is pretty new, like a couple of months, I think.
Okay.
So maybe worth going back and revisiting it.
Any more questions? Okay, thanks very much, Craig.
Thank you all.